Good day everyone, my name is Hui and today I will be presenting my project about system development entitled Handheld Mobile Augmented Reality Gardening Simulation Game with Real-World Environmental Interaction. This project is conducted under PSM1 and my supervisor is Dr. Go. Here is the outline of today's presentation, then I will begin with the problem background. Despite the popularity of gardening and simulation games, many people struggle to engage in real-life gardening due to time, space, and cost limitation. Traditional methods such as gardening books or tutorials often lack interactive, making it hard to stay motivated. Besides that, in existing simulation games, players are restricted to virtual-only environments with unrealistic plant growth and poor connection to real-world conditions. Additionally, there is low awareness of environmental care and sustainability, especially among young users who lack engaging platforms to learn these gardening topics. While AI technology has proven successful in promoting physical exploration through games like Pokemon Go, then few gardening games have utilized AI to create a real-world learning experience. So, these problems point to the need for a more immersive, educational, and interactive solution using modern technologies. Hence, this project aims to develop a handheld mobile augmented reality gardening simulation game with real-world environmental interaction. These are three key objectives. First, to study the principle and requirement of plant cultivation and simulation in horticultural system. Second, to propose a dual-mode AR gardening simulation game that integrates real-time weather effect for outdoor gameplay, a dynamic simulator weather system for indoor mode. And the last one, to evaluate the usability, user satisfaction, and overall functionality of the AR gardening simulation game. Then this project scope include AR mobile apps designed for Android with a single-player experience. All user interface and content are in English. Then this system will offer two modes. One is the indoor mode, which uses a simulated weather system, and outdoor mode, which features the real-world environmental weather data. Then AR Raycast and AR Anchor will use to place a virtual pot plant on real-world flat surface. Then at least 5 type of plant will be used to simulate the realistic growth based on the Royal Horticultural Society guideline. Then furthermore, internet are needed for saving the user progress, fetch the weather data, and also access the location. GPS will be utilized to determine the user's current location and also to fetch the weather condition. Exploring UTM campus to collect the gardening items appear at GPS board, and also other features like tapping virtual plant trigger animation, daily weekly tasks, then buy seed tools and weather items in virtual shop, and the last one is a collection interface which show unlock items and player achievement virtually. Next is the literature review. First, AR is a technology that overlays 3D virtual objects onto the real world in real time, enhancing the environment rather than replacing it like VR. A popular example is Pokemon Go. For this project, handheld mobile AR is used, where smartphone or tablet combine camera views with virtual objects. Built-in sensors like gyroscope and accelerometers help track motion and positioning. Then there are two main AR types, which is the marker-based AR, which use the printer symbol or QR code to trigger content, and markerless AR, which rely on camera and surface detection to place objects. Next, focusing on games, they are goal-driven interactive activities. Then in the gardening simulation game, player will simulate planting tasks. And this project also incorporates real-world environmental interaction, including real-time metadata and GPS-based location tracking for movement-based gameplay. Next, talk about the principle and requirements of plant cultivation. Then look at 5 key requirements plants need to grow, which are the water, sunlight, air, nutrients, and the temperature. Then furthermore, for plant care, the 5 main principles are balanced light, water, and temperature, provide enough nutrients, protect from pests and disease, understand each plant's need, and the last one, regularly check and care for plants. Then for this project, I have selected 5 different type of plants, which is aloe vera, tulips, clivia, rose, and mimosa pudica. Next in this section is the core technology relevant to this project, which is Unity, Game Engine, AR Foundation, 3D modeling software Blender, Weather API, and Mapbox SDK. Next, we move on to the system development methodology. The Agile methodology, specifically a tailored Scrum framework, was chosen. This is because game development involves frequent change and continuous testing of features like AR placement, GPS interaction, and weather-based gameplay. Then, although Scrum is usually designed for teams, but it was adapted for individual project management in this case. The development was divided in short sprint cycles, each focusing on specific tasks such as user interface design, whether API integration, or gameplay mechanics. Then, each sprint follow a structured process starting with planning, then moving to design, implementation, testing, evaluation, and finally a sprint review. Feedback was gathered through supervisor consultation or internal testing, keeping the project aligned with Agile's focus on continuous improvement. Then at the end, the project will enter the system integration and final testing phase to ensure all features work smoothly together. Then come to evaluation phase, which prepare for later real evaluation. The system will be evaluate usability, functionality, and user satisfaction. So first, participant recruitment. There will be 8 to 10 UTM students with Android device taking the test. It is a task-based testing covering the important features of the app. Then after testing, they're required to fill a prostate questionnaire, include linker skill, multiple choice, and open-end feedback. Then all this data will analyzed by combining quantitative and qualitative insights to identify usability issues and guide improvements. Next, both functional and non-functional requirements were identified. Functional requirements include AR port placement, toggle between indoor or outdoor mode, seed planting, tools interaction, GPS-based collection, and task system. Then non-functional aspects focus on platform compatibility, performance, usability, data security, and smooth AR rendering across supported device. Furthermore, is the use case diagram illustrate how players interact with the system, covering key actions such as registering, planting, collecting, and synchronizing data. It also shows the connection with external systems like weather API, GPS, and cloud storage. Next, I will show the interface design of the system. First is the main gameplay interface, which acts as the central hub where the player interacts with the AR garden environment in the game. Next is inventory interface, which organizes the user's collected item into categorized page. Then, besides that, the plant details panel, which display in partially transparent and also display the essential information about the plant's current status and the weather condition. Moving on to the next interface is virtual shop interface, which offering a variety of purchasable items that expand the player's gardening capability and the strategy option. Then besides that, collection interface, which used to view and keep track of players' collectible items. And the last one, the profile interface, which display the important user information and control options for personalization of apps and the notification. Then, this is the project planning PSM tool. The schedule is shown clearly using a Gantt chart. The Gantt chart provides a structured overview of the entire project, breaking it down into phase and sprint for easier tracking. So in PSM2, the focus will shift toward implementing the dual mode AR gardening system. This includes both indoor simulator weather features and outdoor real-time weather integration. Alongside the development, we will conduct usability testing and evaluate user satisfaction to ensure the system meets user needs. The development process will continue following the Gantt chart plan, with tasks organized and executed in sprint to maintain steady progress and alignment with our project goals. So far, the objective 1 has been successfully achieved during this phase. Then objective 2 and 3 are still in progress and will be carried forward into PSM2 for further development and evaluation. And in conclusion, this project presents a novel solution that bridges real and virtual gardening using AR and environmental data. The methodology support flexibility, the feature set ensure realism and interactive, and the evaluation strategy confirm user-centered design. Further development in PSM2 will focus on implementation, testing, and refinement to meet the remaining objective. That's all my presentation. Thank you.